You're doing well. Let's see who we have. This was from last class, so we don't need that. But anyway, good morning to Caesar. Caesar's there at home. Good morning to him. Blanca, good morning. Hector, good morning. And Lauren Wu and Alice Yu, good morning to you. So good morning to all you guys. We got a number of people at home, at least 8 people. So I hope, hope you guys are doing well. We were listening to Crossroads by, this is a Robert Johnson tribute. So if you guys enjoyed that, you can take a look at YouTube. Robert Johnson tribute, Crossroads. Robert Johnson was a blues guitar player. I think he was in the 40s and 50s there. Okay, if you guys know anything about that. So interesting. So Robert Johnson. Anyway, let's get our... All right, so let's go back over here. I'm going to kind of recall the circular functions and the stuff we did yesterday a bit. Circular function information right in here. Okay, so let me get rid of this here for you guys. And remember, this is a unit circle. And so we're going to start with the circular functions. Actually, I'm going to start with this information. I can clear out as much as I can. And remember, we have some identities to work with. We're going to look at 3 identities today called the Pythagorean Identities. Pythagorean Identities. Now you go, Pythagorean, where have you heard that word before? Right? Pythagorean theorem. So if I said to you, since this is a unit circle, here's my angle theta. That distance is 1. Okay? And, you can see it in a lot of ways. This distance here along the circle, that's our arc length. Is that right? So we know that to be S. So the circular functions are to the right over here. So we're going to combine some ideas here. Okay? Now remember, I'm going to go over here to my scratch work. And I'm going to say to you guys, let's write down the circular functions, right? So what do we know? Sine of S or theta, I believe was the y coordinate. Is that right for the circular functions? Cosine of S is what? X. Is that right? And we were working with the unit circle. Okay, so it's back over here. This worksheet here we were looking at that I'm talking to you guys about. And let's see, do we have more people at home? Yeah. So good morning to Antonio. And good morning to Angie. And good morning to Steve. Good morning to you. So remember this unit circle. What's the equation of the unit circle? Yeah, so remember this. This is going to be x squared plus y squared equals 1. So I'm going to share with you guys some algebra this morning. All right? So what I'm going to do here, if you guys remember, I'm going to take these circular functions, and you know what I'm going to do? I'm going to square both sides. Right? So we can square both sides. Square both sides. Okay. You guys with me on that? And so that means we can replace here the x squared with what? Cosine squared s. We can replace the y squared with what? Sine squared s. And so this gives rise to your first Pythagorean identity. Okay, so this is the first one. Pythagorean identity. I don't know. We're going to make that purple or something. Maybe gray. Or we just change this color here. We'll make the unit circle gray. We use this equation. And then this is the first Pythagorean identity, ladies and gentlemen. That's where it comes from. This is actually a proof, in case you guys didn't know. I just prove this to you guys here. Okay? And I'm going to give you guys another note. Remember, if I go back to the circular functions here, right? We got tangent s. What's the definition of tangent? It's y over x. You guys okay with that? I'm going to prove some things to you guys. These are some amazing things. Proof is the best thing ever. So if I use the idea now that tangent is y over x, I'm going to use the circular function here. Okay? Well, where have I seen y before? Y is right here. Right? Y is sine s. So I can say here that this is the same as what? Sine s. This is the y value. Okay? And the x value we know already is what? Cosine x. You guys okay with that? So the x value is cosine x. We're going to put that here too. Cosine s. So there it is, the x coordinate value. So ladies and gentlemen, this is not a Pythagorean identity. However, this is going to be a very useful identity for us. This is sine s over what? Cosine s. Now, we can say here theta as well. Theta as well. It doesn't matter if the angle is the central angle or if it's the arc length. It doesn't matter. It's the same identity. This is what I mean back over here for even and odd functions here. Okay? I'm saying it could be arc length or it can even be what? Central angle. Does not matter. You'll see a lot of books will have theta and not s. Some will have s, but it doesn't matter. Is the arc length. It's the radian measure. Theta is the central angle. Okay, let me get out this. Okay. And then I want you guys to also note, so this is going to be something that we'll use. It's not a Pythagorean identity, but it's an identity nonetheless. And sometimes people, okay. All right, we'll use that. Now, I'm going to do another thing here, ladies and gentlemen. From this first identity I'm showing you here, first Pythagorean identity, right? I'm going to copy this. And I'm going to use some algebra. You say, what do you mean use algebra? Remember from algebra, if we ever have an equation, what are we able to do? We're free to divide both sides of that equation by any number we want as long as it's not 0. You guys with me on that? So what I'm going to do now here is this. I'm going to divide both sides here now by cosine squared s. The left side and the what? And the right side. Okay? So these are the Pythagorean identities. Now on the left side, I have a sum, which means cosine squared s divided by cosine squared s plus sine squared s over cosine squared s equals 1 over cosine squared s. Okay? Just by dividing both sides by what? Cosine squared s. Okay? You guys see that there? See what I'm saying? So on the left side, we're distributing the division. Now, anything divided by itself, what is this portion here? You see what this is? What's this? 1. Good. And now we have to determine what's sine squared s over cosine squared s. Do you guys know? It's going to be what? It's going to be tangent squared s. Does anybody know why? We're going to use a little bit of algebra. Right? A squared over b squared. Do you guys know what that can be written as from algebra? A over b what? Squared. This is what we used here. So if you said to me, what did you do right there? Well, I simply said, okay, let's write this as sine s over what? Cosine s, and we're going to square that, and that's where we're going to use now this relationship that this is what? Tangent s squared, but that's the same as 10. We can put the square right in the middle there. Okay, so I want you guys to notice this, that this is just notation. So far on the left-hand side, what we have here is 1 plus tangent squared s on the left-hand side. We got to see what this equals. Okay? Just doing some algebra. And then the question is, what is 1 over cosine squared? Do you guys know what this is? Well, I'm going to do a square here. Isn't 1 squared the same as 1 squared? I'm going to use that purple algebra again. This is 1 over cosine s, again, squared. Okay, you guys okay with that? We're using this relationship over here. This is the algebra that we're using. But what's 1 over cosine? Do you guys know what that is? That is secant, ladies and gentlemen. So this turns into, because it's the reciprocal, remember from yesterday? So this is secant. It's still raised to the second power, which means this is the same as what? Secant s what? Squared. You put your power there too. So here's a second Pythagorean identity. And ladies and gentlemen, that's what we're talking about today. Pythagorean identities. Okay, first one in blue, second one. And it all comes from that first one. And then I'm going to do a very similar thing here with the cosine squared plus sine squared. And remember, if you say, I looked at another book and that has theta there, what's the difference? It doesn't matter what variable you use. So now we're going to do a very similar thing. We're going to start with the first Pythagorean identity. Now we're going to divide both sides by sine squared s. Okay? And then algebraically speaking, whenever you have a sum divided by a term, we're free to divide both those terms in the sum by that division there. We're distributing division here. Now, notice what you guys see here. What is this here? That's 1. All right, that's 1. Right? I'm going to put it this way. You guys with me on this one? Kind of like that. What do you guys think? Does that look like a 1 to you, the big unit? Yeah, and then we have to know what is cosine over sine squared, right? You're going to say, is that the same as using that same algebra you just showed? Yes, it is. Cosine over sine to the what? Second power. Remember this algebra that we just talked about right here in purple? That's the algebra property. So we're using that right in here. Now, what is sine over cosine? Do you guys know? We got to know what this is right in here. Our cosine over sine. Okay, we already know what sine over cosine is, right? So I'm going to say, here's a note that sine s over cosine s, what is this? This is tangent s. Okay? But you want to know what I'm going to say here? I'm going to write this down. Did you guys know cotangent s, isn't that the reciprocal of tangent? So this would be x over what? Y. Because tangent is y over x. So if I switch that fraction, flip it over, what am I now talking about? Cotangent. And so this is going to be x is cosine s, right? Y is sine s, all by the circular functions. Okay? Remember this is green. This is orange. This is all by definition of our what? Circular functions here, right? Not sure. Yes, orange and what? Green. Orange. Green. All from the circular functions. Anyway. So the point I'm making here, we have another relationship. That cotangent, ladies and gentlemen, is cosine over what? Over sine. And that's another extremely important identity that we use. We're going to put this in our identity list here. Okay, you guys okay with that? These are the proofs of where they come from. And we're going to use those. However, we're still back here, and you say, oh, cosine over sine, this is going to be ultimately what? Cotangent squared what? S. Is that right? Okay, you guys okay with that? We're talking about this one right here. Over here on the right side, can I put a 1 squared there? Right? And you go, what is this? Same algebra. 1 over the reciprocal of sine. What's the reciprocal of sine? Do you guys remember? It's cosecant. So it'll be cosecant S. And again, that's squared, which means this is cosecant squared what? S. So I am describing, and I guess we want to be consistent. Where this identity comes from. Okay. Right here, and that's 1. So let's put it all together. Let's write this down. What you're looking at is cotangent squared S plus 1 is equivalent to cosecant squared S. And ladies and gentlemen, this is your final Pythagorean what? Identity. There's only 3. And you know, there's different ways we can prove the 3 identities. If we go back to my website to say to you, here, you go, okay, let's go to the website, right? You're going to find Math 241. You see this thing called Trigonometry Cheat Sheet? You guys are going to be able to use that in your future. Not now, but in your future. And I'm going to put that here in the comment section here. Okay. So people can see that. And we're also going to scroll on in if we can. Right. So, you know, we're going to use this in the future. So take a look at what you're looking at here. Right, notice you have on the left the definition of that quadrant 1 geometry right triangle, definitions of your 6 trig identities, right? On the right, you got the unit circle with the circular function. So take a look. We've been talking about this trig cheat sheet. I guess we've been studying trigonometry, right? You see what I'm saying? We've been actually studying the course. So you already know about some of these things so far. And I'm going to say this, as you go scroll down, okay, we're going to learn more things, not that today, but look at this formula and identity sheet. Okay, I think I have to do this. Tangent and cotangent identities. You guys know about that so far, right? So you've been studying trig. Good. What else do you guys see on the left? Reciprocal identities. Oh, man. We've seen where these have come from, too. And then you see the what? Yes, you do. You guys, we've seen, I guess we've been studying what? Trig. Is that true? Oh, my God. And then below, didn't we have the even and odd formulas that we looked at yesterday? You guys know what I'm saying? Isn't that kind of nice? So we're going to learn these other formulas, not today, but there's other formulas to look at. And that we even look at degree to radian and radian to degree ratios. You guys remember that? Conversion. And what does that look like to you? My God, unit circle. We've been doing some work. What do you guys think? And that's the what? The trig summary cheat sheet. So we've been working, ladies and gentlemen, and there's some more things to talk about, but not today. But as you guys can see, we've done a lot of significant work, the fundamentals on that trig sheet. Would you guys agree? Right? All right, ladies and gentlemen, we're going to look at how to use these now. What do you think? Nice. How to use things. And then I don't see it there, but I'm going to also bring this into the play. Let me see if I can find it. Photo library. Oh, there we go. Oh, come on. Gotta figure out how to delete some of these photos. And then you say, Mr. Judge, you also have this what? We also have talked about this. What is this? All students take what? Calculus. Haven't we mentioned that too? Man, I gotta put that somewhere. I'm gonna send that to you guys, I think. I gotta find that. Isn't that kind of nice? We've talked about all these things, really. Summarizing these things. Okay, now let's put some stuff together. I'm going to look at some questions that they can ask you that I'll assign. Whatever. How about this? Cosine. Give you guys an example. How do we put this together? How do we use some of these things? They're going to say, hey, we got cosine of S. Your book likes to use T, is that right? You notice your book uses T? That's the same as S. Whatever. And that equals 3/5. And then they say the terminal point of S is in quadrant what? 2. What are the 6 trig ratios? So they're going to make us kind of find the rest of the trig ratios. All right, you guys see what I'm saying? So we're going to look at how to use this here. Get my arm. Okay. What do you think we should start with, ladies and gentlemen? Pythagorean identity. Cosine squared S plus sine squared S equals what? 1. Pythagorean identity. Is that right? Okay, let me share with you guys how to do this. So what they're saying is 3/5 squared, because that's what cosine is, right? Plus sine squared S is 1. You guys know what 3/5 squared is? What's this? It's 9/25. Is that right? Because what's the deal? 3/5 times 3/5. How do you multiply fractions? Right, horizontally across. 3 times 3 is 9. 5 times 5 is 25. Oh, they have some arithmetic. They go, oh my God, Mr. Judge, they're going to make me do arithmetic? Yes. Now what do you guys do? Here's what I'm going to say, what you guys want to do. Solve for sine. They want the 6 trig ratios. So if you solve for sine, that means sine squared S is 1 minus 9/25, okay? Because you're going to have to subtract that 9/25 from both sides. Is that right? You guys see what I'm saying? So far, so good? Do you remember how to subtract a whole number from a fraction? Do you guys you know what I'm saying? There's kind of a nice trick, especially if the whole number is 1. You know what you do? Remember, if you're going to subtract fractions, what do you need? They have to have the same what? Denominator. Is that true? So can I replace this, remember, 1 with 25 over 25? You guys know what I'm saying? Isn't that the number 1? Sure is. And now I can do this arithmetic. So sine squared s, what's this going to be? What's 25 minus 9? Is that 16 over 25? So far, so good? Now, you solve for sine squared, you're supposed to solve for sine. What does that mean? What do you guys use to solve for sine? What is this called? Do you guys remember? What did I just use? Has a name. Square root formula. Yes, you guys use from that. Remember, I think I even gave you guys some of that stuff for homework. I wonder why I did that, because I knew you guys were going to have to use it. Is that true? All right. Now, what about this radical? You guys remember? Properties of square roots. The square root of a over the square root of b is the square root of a over the square root of b. Is that right? In other words, using that property here, this is the square root of 16 divided by the square root of 25. What's the square root of 16, ladies and gentlemen? Yes, it's 4. And what's the square root of 25? 5. Okay, you guys okay with that? What do you guys think? Is that pretty good? Now, what does this mean that you're looking at? You guys know what the symbol is here? What's that symbol? That's called the plus or minus symbol. What does that mean? That means the following. I'm going to move this down here. That means sine s is positive 4/5 or what? Sine s is negative 4/5. What do you guys think? Plus or minus? Go back up a little? Sure. Do you guys like the fact that you have videos to go back and watch just in case? I don't know. Is that helpful? Okay, good. So all of this nightmare you guys see me having to put up in the morning and take it down, that's worth the trouble? All right, good. Glad to hear it. Wrong button. Glad to hear it. So there's 2 answers, ladies and gentlemen. Now here's the deal. Since there's 2 answers, which one is it? Which one is the correct one to use? There's only going to be one. Which, Is it positive or is it negative? Anybody know? What's the deal? Which one is it? Go back up here. What did they say? The terminal point of S is in quadrant what? 2. Go back up here. Quadrant what? 2 somewhere. I don't know what the angle is. Okay? You guys remember what I'm saying? I think we want to use a highlighter. They're saying that the angle is somewhere in quadrant. Come on. The angle is somewhere in quadrant what? 2. What do you know about quadrant 2? How do you know sine's positive? All students take calculus. There you go, ladies and gentlemen. That's how everything fits together. Oh my God. So that second piece of information is extremely helpful, isn't it? You start with a Pythagorean identity, and then you get what? You get to use that second piece of information. So sine here is 4/5, and you started with cosine. What's cosine? 3/5. What do we need, ladies and gentlemen? How do we get tangent? Tangent, ladies and gentlemen, we got to get all 6 trig identities. Tangent is what? Sine over what? Cosine. Okay, and what was sine again? Oh, 4/5. What was cosine? Oh, 3/5. Is that true? You guys see what I'm saying? Nice. What do you guys think? What do you think they're going to make you do again? More what? Arithmetic. So, isn't it true? This is the horizontal definition. Four fifths divided by what? 3/5. 4/5 times 5/3. What happens now? The 5 goes away, and what does this equal? What do you think tangent S is? Tangent S, ladies and gentlemen, is positive what? 4/3, because we use the identity correctly. What do you guys think? So if we have the first 3, sine, cosine, and tangent, what do we get free of charge? What's the reciprocal of tangent? Cotangent, that's 3 what? 4ths. Nice. What's the reciprocal of sine? What's the reciprocal of sine again? You guys remember? You just flipped this fraction over, but what is it? It's cosecant. Yes. Oh, man. What's the reciprocal of, what do we have here? What they gave us of cosine? It's secant. Is that right? So I know all of those definitions. And this is 5/3. So, ladies and gentlemen, is that 6 trig ratios, the 6 that you're talking about? That's what they're talking about. So, ladies and gentlemen, notice I make use of everything we've been talking about. Everything. Yes.
So the question said the terminal point in the second quadrant, right? But the cosine is positive.
This is the initial point, and then this is the what? Terminal point. Is that right? And I'm reading it here. Terminal point is in quad. I actually made a mistake. I made a mistake. Because how big of a mistake? Let me go back. I made a mistake. I must still be suffering from what? The Madura vaccine. Can't even lift my arm. Well, I'm glad you asked that question. The starting point was wrong. It's cosine, but the process is the same. Cosine S is what? Minus 4/5. Here we go. That's what we're looking for. Okay. Okay. Let me actually do this here for you guys. Okay. Little OCD. I'm doing an even question because I like giving you guys the odds. And I mix the even. I mix the question up. Okay. And this terminal point is in quadrant what? 3. Good job. I'm looking at 64 in your book. Okay? Let's get out the big eraser. I'm going to get out the big eraser. You guys have the process in your notes here. The process I went through is the process. But I'm going to have you guys try it out. Yeah, today's like a day where you just go and have breakfast. What do you guys think? I was going to go have breakfast. Every day's a day you have. I think I'll go to that Marsden's place and I'll go have some pancakes or something. Or I'll go have a nice breakfast. What do you guys think? Every now and then you should treat yourself, right? Maybe it's a good day to treat yourself. Let's go look at this picture then. So it's kind of accurate. Darn it. All that great work gone to waste. Well, it's still good work. The process was good work, but so you have a beer or you go have breakfast. It's too early for a beer. Quadrant 3? Okay. So. Yeah. Yeah, but I don't know about you guys. You guys are young kids, but when I start drinking beer, I've gotten to the point where I crave it more than my coffee in the morning. Isn't that horrible? Something's wrong. When you wake up and you want a beer, not coffee? I don't know. So when I start feeling that way, I know, oh, stop drinking the beer. Because I need some coffee. I'm sorry, I need a beer. Quadrant what? 3. Still can't even do it right. God, maybe I should just go home today. I thought I had to go home yesterday. I'm not even useful today. Oh my God. Don't even know my quadrants, ladies and gentlemen. So I'm going to have you guys take a look at this one here. Use the process I just showed you guys. And I don't even have a cup for coffee. And I'm going to give you guys some time to get all 6 trig ratios. What do you guys think? How much time do you guys think you'll need? 12 minutes? Here you go. Let's see what you guys get. All right, ladies and gentlemen, did you guys get some answers by any chance? Hopefully. Let's see if we can get things together to do this morning. So remember, how do you start? They give you cosine. So how do you really start with this? You start with a Pythagorean identity. Okay, so you're going to say cosine s, remember that's squared, plus sine squared s squared is 1. So that means since cosine is what? Negative 4/5? We square that. Okay? And negative 4/5 squared is 16 over what? 25. Okay? Now we can solve 1 minus 16 over 25. Now remember, use that trick I showed you. You're going to be using that trick a lot in your life, right? See, the denominator is 25, so I can replace 1 with what? 25 over 25. Okay? So you get sine squared s is, what's 25 minus 16? It's 9 over 25. Okay? So from here, we use what? Square root formula. Plus or minus square root 9 over 25. Now, you're going to use the algebra here to simplify that radical. Okay? That's going to become square root of 9 divided by square root of 25, which would be 3 over what? 5. So sine s is plus or minus 3/5. What does this mean? Sine s is positive 3/5, or sine s is what? Negative 3/5. And now we're at the place where what? We have to decide which one is this? Which one is the what? Solution. Okay, because of the meaning here of plus or minus, right? Plus or minus square root formula. All right, go back to the original piece of information, right? Because we're going to have to say, oh, quadrant 3, what's the deal with quadrant 3? Right? They're saying here that the terminal point is in quadrant what? 3. Is that true? What do you guys know about quadrant 3? Tangent's positive. What does that mean about sine? Sine's negative. Yes. Sine's negative. Let me get my... There's your solution for sine. Okay, you guys okay with that? Now, can you get tangent? Sure. You might say tangent is sine over cosine, which means negative 3/5 divided by, what was cosine that they gave us? Negative 4/5. So we got a negative over a negative, which does give you a what? Positive. So it's 3/5 divided by 4/5. I can just change the sign now, or 3/5 times 5/4. 5 goes away, and ladies and gentlemen, tangent is really what? 3/4. Okay? I'm going to write that down somewhere. So if tangent is 3/4, then we know what cotangent is. Is that right? What's cotangent? Is that 4/3? Okay, we got sine is negative 3/5. That means what? What's the reciprocal of sine? Cosecant. Remember that? Cosecant s is negative 5/3. Flip that fraction over. And good. Reciprocal, and then secant. Reciprocal of cosine, it's negative 5 what? 4ths. There you go. There it is. Okay, should we try another? Let me take a look. Try another. Tangent. And the book says t, but you guys know it's the same thing. Tangent is 1/4. Terminal point, quadrant 3 again. Okay, how do you think you handle that one, ladies and gentlemen? Which Pythagorean identity do you use here? Right? Remember, this is in the section where you have the Pythagorean identities. So you're going to put here 1/4. You're going to square that, and that should be secant squared. Is that true? So you get 1 plus, is that 1/16? Okay. And then you got 1 again. I have to add. I have to have the same denominator. The same trick applies. See that there? What do you get? 17/16. And that's secant squared. Okay. Square root formula, plus or minus, square root of 17/16. Is that true? Square root formula from algebra. Solving for secant. So I'm going to have to simplify this radical using those properties, that quotient property, right? Now, square root of 17 we can't simplify, but square root of 16 is what? 4. So we're using that information we talked about in the past. Square root of 17 over now 4, ladies and gentlemen. Okay? Square root formula. That's where the algebra comes in. So plus or minus now becomes the following. Secant S is an positive. Secant S is what? Negative. Okay, so we're at the point again where we have to answer. Which one is it? Well, quadrant 3, what do we know about quadrant 3 again? Right, tangent was positive, which means cosine's negative. Why do we care about cosine? Because the reciprocal of cosine is what? Secant. So you're right. It's going to be the what? The negative answer. And, since we're on the topic here, this means cosine S will be negative 4 over what? Square root of 17. Is that right? Now, how do you rationalize the denominator again? Multiply top and bottom by the square root of 17. Is that true? So you're going to have cosine S going to be negative 4 square root of 17 over 17. Okay. And go back here since you have what? Tangent is 1/4. What does that mean? Cotangent's what? It's 4 over 1, which equals what? 4. So you have that one too. 4. What do we need? What's missing? So how do we get sine? What do you guys think? How do we get sine? Here's what I'm going to say to you guys. Tangent is sine over what? Cosine. Is that true? Is that right? Can I use a little bit of algebra? There's no law against using algebra. That's why it's here to use. Get rid of cosine. You know what this means? Sine can be written as cosine times what? Tangent. So I know what cosine is. It's negative 4 square root of 17 over 17. We just found it. And I think we know what tangent is. Was it negative or positive tangent? It's positive 1/4. So notice we were given those things, right? What do you think this means now? We got sine. And if we have sine, what do we have? Cosecant. It's the reciprocal. But you have to rationalize the denominator. Okay, so it's negative 17 square root of 17 over 17. Or we say cosecant is what? Negative square root of 17, ladies and gentlemen. So you're going to use those particular what? You're going to use those identities, right? And then if they say to you something like this, they say, okay, secant, I know they put t. Secant is 2. And then they say sine is positive? No, negative. Let me double check. Okay, so what do you think you would do with this? What Pythagorean identity do you have here? Say, Mr. Judge, I have that same one. Isn't that 1 over tangent squared s equal to secant squared s? Was that one we work with today? Is that true? So what does that mean? 1 plus tangent squared s is 2 squared. Is that right? So I'm going to actually solve for tangent squared s, which is 4 minus 1. Tangent squared s is the value 3. Okay, square root formula. Tangent s is plus or minus square root of 3. Is that right? Which means tangent is what? Square root of 3? Or tangent is minus square root of 3. Which one is the solution? Because you got 2 plus or minus. Well, why would tangent be negative? What do they say here? Sine's negative. Cosine is 1/2. Cosine is what? Positive. Is that true? You guys okay with that? So if they're telling me sine is negative, then tangent has to be negative. Why? Why is tangent negative? Because tangent is what? Sine over what? Cosine. Is that true? Okay, now what do we have here? If we have cosine and tangent, I got tangent, I got cosine. Can I get sine? What does this mean about sine? Can I use algebra again? That means sine will be cosine times what? Tangent. Is that true? If I multiply both sides by cosine? You guys with me on that? You guys see what I'm saying? A little bit of algebra, ladies and gentlemen. So what was cosine again? They told us cosine is what? 1/2? So this is 1/2. And what was tangent? Negative square root of 3? So it looks like sine here is negative square root of 3 over what? 2. And if I have sine, I have what? Cosecant. What did I just do? Yeah. Sine, cosecant. What about this? What about cotangent? It's negative 1 over the square root of 3. Is that right? Which would be negative square root of 3 over 3. How do we get that? Rationalize the denominator. Is that right? Tangent, cotangent, sine, cosecant, secant, cosine. There it is, ladies and gentlemen. All 6 what? Trig identities here. Easy breezy. What do you guys think? Okay? A little bit of algebra? Anybody take algebra before? Yep. Some algebra here. Is that right? Intermediate algebra, beginning algebra? It's okay. What do you guys think? Is that fine? No? Find out, where are we at here? What time to get out of here? 35? Anyway. Oh. Can't even raise my arms. Oh, my left arm. What do you guys think? Not bad? If you know your identities, what do you think you want to do? Yeah, if I were you, I'd get a whole other sheet of paper, write down the identities that we've gone over really. We've highlighted them, and in fact, if you even look at that sheet I put in the comment section, that summary sheet, there's a lot of that stuff we talked about really, and maybe highlight that and say, okay, this is kind of where we're at, right? And the first test, of course, you want people to know these things. But after the first test, you get to use that cheat sheet, So that's kind of the idea behind it. So that's the kind of, thing that you're facing. But, we did go over every one of these gory details. And anyway, we're going to let you guys go a bit early. Okay? And I would cancel my classes if, darn it. Got a calculus class. They got to learn about differentiability. What is that? Yeah, exactly. You got to pay more fees, take more courses to get there. You guys know what I mean? The what? This formula here, the cheat sheet formula? Oh, all students take calculus? Let me see what I can do. Let me see this. Hold on. Let me see. I'm going to copy that. So I had a request. Darn it. All right, I'll see what I can do. Okay, guys, take care. Have a great day. We'll see you guys tomorrow.